Now this is part 4 of your question number 3. State whether the lattice energy of calcium chloride is more or less exothermic than the lattice energy of magnesium fluoride. Explain your answer. So lattice energy depends on two factors. One is charge, value of charge, and other one is the radius of the cation and anion. So in this case, it only depends on the size of the ion, because magnitude of charge on both cases are same. You can see in this calcium and calcium fluoride and chloride. First of all, see magnesium and calcium, magnitude of charge is +2 on both ions. Similarly, magnitude of charge in both ions is -1. Both anions, you can see it is -1. So we will compare their sizes. In both cases, calcium and chloride, you can see in both cases, in cation case and in anion case, calcium and chloride both have larger size of ion as compared to magnesium and fluoride ion. So calcium chloride lattice will be less exothermic, as in both cases their ion size are larger. Now B part of this question, the sulfate of the group 2 elements vary in solubility down group 2. The first question is, part is, give the name of two solutions that could be mixed to form barium sulfate. So to make barium sulfate, as we know barium sulfate is insoluble, we need two soluble salt. One salt should contain barium and another soluble salt should contain sulfate in it. So we will take nitrate of barium and we will take sodium salt of sulfate, because both are soluble. This is the soluble part. Now the second part, state and explain how the solubility of sulfate of group 2 elements vary down the group. So before explaining solubility, I would like to remind you that solubility depends on two things. One, lattice energy, another one is hydration energy, right? So if lattice energy, because to be soluble, lattice must be broken down into ions, and ions are surrounded by a water molecule to make ion dipole interaction, and that is called they release energy, and that is called hydration energy. So if lattice energy is less than hydration energy, then the salt will be soluble. Now heat of solution depends on two main factors, lattice energy and hydration energy. So in this case, as we move down the group, solubility of sulfate decreases down the group. If we compare their lattice energy and hydration energy, both depend on magnitude of charge and both depend on size of an ion. Size of ion. So as we move down the group, both lattice energy and hydration energy decreases down the group because size increases. However, delta H of hydration in this case decreases more significantly. That is why delta H of solution become less exothermic. Thank you. Okay, one thing more. You need to understand this formula as well, that heat of solution depends on lattice energy and hydration energy, and you already know both decreases down the group as the size increases, because both depends on size and magnitude of charge. So in this case, in the case of sulfate, both lattice energy and hydration energy decreases down the group. Lattice energy and hydration energy both decreases down the group. However, hydration energy decreases significantly. So your negative value decreases significantly and your positive value is still larger than this negative value. So you get your answer in positive. So it become endothermic or it become less exothermic as we move down the group. Hope you understand. If you have any question, you can ask in a comment section.